2003, the National Science Foundation launched a $10 million project called EarthScope. Since then, crews have been installing hundreds of seismic systems in big rolling swaths across the country, digging holes, burying equipment, and powering it all with solar panels every 40 square miles.
So solar panel pick up the sun, so we charge to the battery and inside the hole, so we keep it running all day long.
Nguyen is an engineer living in Western Washington. He's been part of that crew since 2006. Every 2 years, they dig up the equipment and move it east. But when they found that stress point or ETS events in our area, they decided to come back.
So each one of them we monitor by radio, by a satellite dish.
Starting next week, Nguyen will help to reinstall those sensors to study just what's happening around here and help all of us better prepare for what's to come.
On one farmer's cattle ranch in very rural eastern Virginia, one construction crew
This powers the whole station.
is about to power up that thing.
The seismic sensor.
This is it.
This is it, the earthquake sensor.
The idea of a CAT scan, right, is to see beneath the surface.
Now, just like a doctor would take a CAT scan of a broken person, something called EarthScope will scan our broken planet. As you know, the tectonic plates that make up our country all came from somewhere else.
There's blocks that were originally in Africa, blocks that are related to South America. So we'd love to know how those actually link up below the surface.
You don't know that? You don't know how the world is connected just yet?
Well, we have a good idea near the surface. We don't have a particularly good idea below the surface.
That's why James Madison University Associate Professor Steve Whitmire and other scientists need this new kind of detector that can pick up much more than just earthquakes.
Got it?
We're talking earthquake detectors so sensitive. The gentle footsteps of my friends back there are easily picked up in the hole where Doan's sitting right now.
It can pick up the people walking around, people driving in.
This is what us walking around here looks like. Footsteps, nuclear bomb tests, earthquakes around the world. The computer sees them all, knows the difference, and
They know exactly where it came from too.
This would be a cool story if this was the only site. But this is not the only site.
That's right.
hundreds of identical detectors are now online across the eastern half of the continent. And the crews are constantly moving them from coast to coast, creating the most accurate earthquake map of the United States ever drawn.
So we're trying to get a profile of the whole continent.
Even extreme weather can move the Earth. This is how Sandy looked as a storm. And this is how EarthScope saw it as an earthquake-like event all the way up and down the East Coast.
As soon as they finish construction here, this site will go live.
Putting the pieces together so science can understand the ground that connects us all. In Eastern Virginia, Dave Malkoff, The Weather Channel.
Now, with the EarthScope seismic stations,
Go ahead, Doan.
we can see much more clearly than we've ever been able to deep within the Earth.
The Transportable Array is an ambitious experiment that is continental scale. It was designed to get identical seismic instruments, one station every 70 kilometers on this amazingly regular grid, with each instrument recording for 2 years and then moving gradually across the country.
Once we get to our site, either I or Doan will muck out the vault. Usually there's a little bit of water left over from the concrete drying. Then I go in and I start putting all the solar panels up. Doan starts his installation. It takes us about 2.5 to 3 hours, generally, if everything goes well, to complete a site. So this is like a hard drive. Records all the data. And then right here we'll mount the modem, which sends the data out over the internet through the cellular network. We have a charge controller in here. Takes the power of this from the solar panels and charges our 2 batteries. And that's pretty much everything other than the sensor. Are you ready?
Yep.
The seismometers installed at each of the transportable array sites are high-fidelity sensors that cover and capture all of the motions of the Earth that are produced by earthquakes.
Got it? Got it.
And this allows the scientists to use earthquakes as a tool to look at the structure of the continent. Before, it was difficult because we could see a change at one given station, but the next station may have been 100, 200 kilometers away. So there's no pattern at all. Now the regular grid means you can see these waves from earthquakes clearly correlated from one station to the other.
All right, ready? Yep. The data gets sent out live 24 hours a day, 7 days a week. So we pull it up online with our laptop and open the site remotely, check everything, make sure everything's going good, do some thumb tests.
East to the east. It's coming in, Mike?
Yeah, oh yeah. Okay. Very good. Looks really good.
Yep.
All of the stations of the transportable array record data continuously. So it's sampled at 40 samples a second, every day, all year long. Then you multiply that by 400 stations, then you start getting to large quantities of data.
sẽ hát tôi ngợi khen, hát ca ngợi Chúa tôi yêu kính. Tôi sẽ hát tôi ngợi khen, hát ca ngợi Chúa tôi nhân từ.
Trọn đời tôi hạnh phúc sẽ theo tôi, trọn đời tôi thương xót sẽ theo tôi sẽ ở trong nhà được rêu và buông
Thi Thiên thứ 66, câu 2, câu 3 phần A. Tác giả khuyên chúng ta hãy hát ra sự vinh hiển của danh Ngài. Hãy ngợi khen và tôn vinh Ngài. Hãy thưa cùng Đức Chúa Trời rằng các việc Chúa đáng sợ thay. Tin Lành TV sẽ mang đến với quý vị âm thanh của những bài thần ca để thuật lại công việc đáng sợ lạ lùng mà Đức Chúa Trời đã làm trên đời sống của các con dân Chúa.